1. Okay, so this is just sort of a special type of normal distribution that we use in statistics all the time. In standard normal distribution, 0 represents the mean, and then the positive integers represent the standard deviations that are greater than the mean, and the negative integers represent the standard deviations that are less than the mean. The empirical rule, this is going to be very, very important for this chapter. Okay, probably about 80% of the questions on the test deal with this. Okay, it says that 68% of all the data falls within one standard deviation of the mean. So meaning that 68% of the data falls between one standard deviation below and one standard deviation above the mean. Okay, flip it over. 95% of the data falls within 2 standard deviations from the mean, meaning from 2 below to above. 95% of all your data falls in that range in a standard normal curve. That's a lot, right? Okay, and then 99.7% of the data falls within 3 standard deviations of the mean. So almost all of your data falls within 3 standard deviations of the mean. Okay, in a standard normal curve. Questions? Okay, and we can separate it into different pieces as well. So that's what I'm going to do here for you. Okay, if 68% of the data falls within one standard deviation of the mean, that would mean that 34% falls between the mean and one lower than the mean, and 34% falls between the mean and one standard deviation above the mean. Okay, so it's split there, half and half. Okay, if 95% of the data falls within 2 standard deviations of the mean, and I already used 68% of it, then I can find what these little bars on there represent. Okay, and that would be 13.5% and 13.5%. Because total, all 4 of these add up to be 95. All right, and then lastly, 99.7% of the data falls within 3 standard deviations of the mean. And so I can fill in these last little bits, and that would be 2.35% and 2.35%. If I add all of these numbers that I just wrote in up, are they going to add up to be 100%? Not quite, right? What would they add up to be? Very good, 99.7. Not quite all of it, but most of the data falls there, okay? That is something you have to memorize, have to for this chapter, okay? So it is going to be really important that we know that. You don't have to memorize it today, but by the end of the chapter. Okay, so flip it over. Let's do some problems with this. You can use the empirical rule for normal distributions to estimate the percent of data within specific intervals of the normal distribution. Determine each percent and then explain your reasoning. Shade the corresponding region under the normal curve and then tell whether the distribution represents the population or the sample data. Okay, so what percent of data is greater than the mean? Okay, so that would be from the mean of this. What percent would you think that is? 50? Yeah, right? 50% of the whole. Yes? 49.85. I understand where you're coming from. We're also going to include this little bit after the 3. Okay, so that's where the 50 comes in. Okay, other questions there? Okay, go to the next one. What percent of the data is between the mean and 2 standard deviations below the mean? Okay, so between the mean and 2 standard deviations below the mean. Okay, so this is the part we're looking for. How do you think I would compute that? Good. So we're going to add the 13.5 for here and the 34 for here. We add those together. We would get 47.5%. Okay, on the first one that you did, was this talking about a population or a sample, and how would you know? Very understatement here. You really have to look for it. The little symbol on the bottom, which we call, remember? Sigma. Okay, and so if that's that little symbol on the bottom, then this is called this is talking about a population because of sigma being your standard deviation. And then what is the standard deviation being represented as here? S. So that is going to be the sample. Okay, they both represent standard deviation. One is for the population and one is for the sample. Okay, let's see. What percent of the data is between 1 and 2 standard deviations above the mean? Okay, so we're above the mean, we're on the right. 1 and 2 standard deviations above the mean. So just this little bit here. You don't want the whole thing all the way out to here. You just want this little bit, which would be, what'd you say? 13.5? Good, 13.5. That's sort of just a memorization one, right? Is this population or sample? Sample. Okay, why don't you work with your group and see if you can figure out this one. And this one's kind of tricky, so really talk about it. So more than 2, I'll shade in the piece there. Further than 2. It's not saying like more like right. Okay, I'm seeing awesome answers here. So more than just the answer, I'm interested in how you got the answer. Okay, so how many groups got it to be 2.5? Good. Okay, give me, how about group 5? Tell me how you guys did it, because you told me in the back and I liked it. Mm-hmm.
So that was, if you combine all the rest of the 0.7, so then you put that last section and divide by 2.
Good. So 0.3 is going to make up this little tail and this little tail. Divided by 2, so that would just be 0.15. And then you added them together. So group 5 did 2.35 plus 0.15 and got the 2.5. Anybody do it differently than that? Connor. Cool. I like that too. Okay, so he said from 2 to 2 is 95%. So that means this tail and this tail have to be 5, and then you divide by 2. That's 2.5. Cool. I like it. Anybody else do something different? I know you did, because you told me. Yeah, go ahead.
Okay, so we did 100 minus 99.7, and then divided by 2, and then we added 2.5.
Cool. Okay, so you did the 100, like the whole thing, minus the between the 3, and then, yes, very good. That was good too. Anybody do anything different than that? See how many different ways there are to do that, okay? Now, all of them are correct. Very good. Is this population or sample? Population. Good. Okay, flip it over. Okay, so it says use the normal curve to answer each question and explain your reasoning. Shade the region under the normal curve to represent your answer. Okay, so they're not giving you the curve here. So the average height of adult males in the population is 70 inches with a standard deviation of 4. Okay, so we're going to make our normal curve like we did the first day. Draw your normal curve in. Without messing up there. There we go. Woo! It's too shaky. There we go. Okay, and I'm going to put the 70 in the middle because that's the mean. How do I get the other tick marks? Add 4 or subtract 4. Okay, so I'm going to have 74, 78, 82. And we're adding 4, right? 74, 78, 82. Did I do that right? Okay. And then subtract 4. So we got 66, 62, and 58. Everybody okay with making the curve? Okay, so now I'll read the question. It says, what percent of adult males have a height between 62 and 74? Okay, so now I want, this is the mean, and I want between 62 and 74. I want that shaded part. How do you think I need to go about doing this? Can we add all the pieces together? Okay, so what's between 74 and or 70 and 74? 34%. Color here. So 34% here. What's between 70 and 66? 34. And then 66 and 62 is 13.5%. So then I can add 34, 34, and 13.5 and get 81.5%. Okay, let's talk about this one. So I made my curve. 65 was my mean, and then I had to add 3.5 or subtract 3.5 to fill in my standard deviations away from the mean. And then it says what percent of adult females are taller than 68.5? So I want 68.5 and up. Anybody have any suggestions how to approach this one? Any of these numbers in between would be like between 68 and 72. So actually we have to include that block. Because that would be like 69 and 70 and 71. Okay. Yes. It is. How'd you do it?
So, 68.5 and 72 is 13.5%.
Okay.
And we established that 72 onto the end is 2.5%.
Good.
In the previous problem, and so I added
13.5 plus 2.5 would be 16. Good. Anybody do it any different ways? So it's everybody did it that way? Okay. It's interesting to me. I like that you guys all approach the problem by adding all the pieces. You could also approach it by like what's 65 on 50%, right? What is the piece that you're not including? So how else could you do it? 50 minus 34. That's fine. Either one. And there's no like right way or better way of doing it. It's just however you see it. Okay? Either way, you should be getting the 16%. Questions? Okay, last one. What percent of history test scores are between 63 and 70 points? How much? 34. And that's just a flat out memorization one. Okay? Questions?